Hi all, this is Divya. I'm working as an assistant professor in the Department of Biomedical Engineering at Sri Shanmuga College of Engineering and Technology. So today I would like to present the topic Embedded System Design Process. So what are all the steps we need to follow while designing the embedded systems? We will learn about it all. So why should we study about the design process which are involved in your embedded system? There are two objectives. First, it will give us an introduction to the various steps in the embedded system design. Okay, so there is one, not only a single step which makes a whole embedded system, right? So there will be various steps involved in designing the embedded systems. So with the help of studying the design process, so it introduces, so what are all the steps, various steps in your embedded system design. So next thing is, it will allow us to consider the design methodology itself. So what design methodology an embedded engineer should follow. So we will learn these two things while studying about embedded system design process. So design method, why design methodology is important? So there are three reasons for that. First one is, we can ensure that we have done everything what we need. And the second one is, so it will allow us to develop the computer aided design tools. So which helps to make the products much easier. So next one is, so with the help of this design process, the design team members can communicate easily with each other. So we can design the embedded system in two ways. So the first one is top-down approach and another one is bottom-up approach. So what is meant by top-down approach? So this is your top-down approach. That is first thing is you have to get requirements for the product, what we need to design, and we have to refine it and make the specification. And the next one is we have to draw the architecture, and the next thing is we have to buy the components, and integrating all those components we can make the entire system. So this is your top down approach. So bottom up approach is opposite of this top down approach. So in what is the process going in your bottom up approach? So the first, the system integration will be happen, and the next components, then architecture, then specification, then we'll go for requirements. So we can make the embedded system in both top down approach and bottom up approach, depending upon the designer who are designing the system, and also depending upon the application for what we are using designing your embedded system. So we need to consider the major goals of the design. So first one is manufacturing cost. So we have to consider the manufacturing cost of the product. It is a very most important thing. And the next one is performance, both overall speed and deadlines. And the next one is power consumption, how much power it will consume. So how much power it will consume, that is it requires a battery operated device or a plug-in device. So that thing will be considered as the main goals of the design. So these things will be considered the main goals of your design. And so in at each step of the design we add details like we must analyze the design at each step to determine how we can meet the specifications. Okay, so in each and every step we have to analyze that whether we are meeting our specifications or not. Okay, then we can refine them. If you want to add any detail or if you want to delete anything, so you can refine the design. Okay, and we must verify the design to ensure that it still meets all the system goals such as cost, speed, and so on. So requirements. So what is the first step of our design process is requirement, right? So first step is, this is your initial stage. That is what is my requirements. So requirements is capture the information for use in creating the architecture and components. That is, first we have to gather the informal description from the customer what actually he need. So that is your requirement. Okay, so we have to refine the requirements. We have to refine the requirements what is given by your customer. So that refined form is called specifications. Okay, that contains enough information to begin designing the system architecture. So separating out requirement analysis and specification is often necessary. Why it is necessary? Because of large gap between what the customer can describe about the system they want and what the architects need to design the system. So both the things are entirely different, right? So what the customer requirements may or may not meet how to manufacture it, right? So that can be done, that can be refined in your specifications forms. So the requirement may be functional requirement, or some of the non-functional requirements or performance. So first one is performance. That is how speed, what is the speed of the system? How faster the response of the system is. So that is what this in this performance requirement will be mentioned. So as we have noted, the performance may be combination of soft performance metrics such as approximate time to perform the user level functions and hard deadlines by which a particular operation must be completed. Okay, so the performance means we can fix the deadline. So if the loss is heavy, that can be considered as hard deadlines. If the loss is not light, that is light, that can be considered as the soft performance metrics. Okay, so the next one is cost. So the cost which involves, so what are all the cost will be involved? Manufacturing cost and the non-recurring cost. So manufacturing cost include cost of the components and assembly, but non-recurring cost, it includes the cost of personnel who are involving it, this labor cost and other cost of designing the systems. That will be considered as a non-recurring engineering. And the next one is physical size and weight. So what is the size, physical size and weight of the system to be designed? So what is the customer expectation? So that can be mentioned here in this physical size and weight column. And the next one is power consumption. So what type of power device, battery device they are need? That is, whether it can be a battery operated device or it can be a plugged in device. So that will be mentioned in your power consumption row. And the complete requirement form will consist all these things. The first one is name. So the name is, this is simple thing but helpful. So how the name of the system should be? So you should give a name to the project that should tell the purpose of the machine. For example, if you are giving name for machine as washing machine, so what will the purpose of that washing machine? So it will wash the clothes, right? So by giving name of the project, it should tell the purpose of the machine. So next one, purpose. So that is, you have to give 1 or 2 line description of what the system do. Okay, so if you can't describe the essence of your system in 1 or 2 lines, the chances are that you don't understand it well. Okay, so the next one is inputs and outputs. So what type of input you are giving to your system? So whether it can be an analog data, or it can be a digital data, or you want to give mechanical inputs. So that can be defined here. And the next one is data characteristics. So periodically arriving data such as digital auto samples or how many bits per data element. So these can be defined here in your data characteristics. And the next one is type of output devices. So what type of input or output device you are using, whether it can be a button or it can be a touch screen or it can be an analog to digital converters. So what type of input devices you are need to be included in your system, and what type of output devices you need to include in your system. So that is, it can be a display or it can be an LED light or it can be an audio message. So whatever it may be, so that can be included here in the types of input output devices. So the next one, functions. So this is what more detailed description of what the system does. Okay, so here you can give 1 or 2 lines description of the what system is supposed to do, that is purpose. But here the function is more detailed description of what the system does. So a good way to approach is to work from the inputs and outputs. When the system receives an input, what does it do? How do user interface inputs affect these functions? How do different functions interact? So all these things will be mentioned here in a function. And the next one, performance. So like we have discussed in the last slide. So what is the performance of your system should be? So how fast the response from the system should be, so that can be mentioned here in your performance. And the next one is manufacturing cost. So what are all the components you are involving in your will be involved in your embedded system design process, so that cost of each and every hardware components. So if you don't know exactly, that is not problem. The approximately you can how much you can afford to the system for components. Okay, so that can be mentioned here as a per manufacturing cost. Okay, next one is power. So what type of power you need to give for your system, whether it can be a plugged in device or it can be a battery operated machine, that should be mentioned here. And physical size and weight, so you should give some indication where physical size of the machine, it can be a small compact size or it can be a large size that can be in placed in your room. Okay, so that can be mentioned here in your physical size and weight. And this is your sample requirement form. So all these requirements will be mentioned here. So that can be this sample requirement form can be given to your customer, and they should fill it and return it. So you can see an example requirement analysis of GPS moving map. Okay, so what is the name of your device will be? So GPS moving map. So for what purpose you are using GPS moving map? For consumer grade moving map for driving use. And inputs. So what are all the inputs you want to give? You can have power button and 2 control buttons. And what outputs you want to give, you want to get from your system. So it can be a backlit LED display, so that should display your GPS moving map, right? Next one is functions. So what function it should perform? So it should always display current latitude and longitude, right? So next one, performance. So how the system should perform? It should update screen within 0.25 seconds upon movement. So if it find any movement of the machine, so it should update the screen within 0.25 seconds. And the manufacturing queue, you can approximately quote it as $30. And the power, so it may consume 100 milliwatt. And physical size and weight, so it can be no more than 2 or 6 inches, and the weight can be 12 ounces. So these are all the approximate things that can be get from the customer. Thank you.